So for this video, we will be doing mesh current or loop analysis or mesh analysis with a supermesh. And first, I have modified my steps from the previous video, and it's down here. And it says if a current source is in between two meshes, which is a supermesh, and I'll explain that in a little bit, we write one single KVL equation around both meshes, and this basically means that we write both if the currents in both meshes are I and IB, we do not combine them into a single current, and we write them as one entire equation. And the next step is to write an equation that includes both currents, so I and IB, in terms of the current source. And we'll do that right now. So first, the way we know that this is a supermesh is that there is a current source over here in between two meshes here and here. So now that we know that this is indeed a supermesh, we'll be labeling our meshes. Mesh number 1, 2, 3, 4. That is the first steps, according to my steps. And then I will say that this is I1, this is I2, this is I3, and this is I4. So now, starting with the first loop, we can see over here that I1 is going to go up, like there. So this is 2I1, then it would go here, and it would usually go down here, then here. However, since we do indeed have the supermesh, this whole in-between branch is kind of crossed off. I1 will be going that way, that is true, but since that in-between branch is crossed off, we won't include that into our equation, and this switches into I2. This goes down into I2. So this becomes plus I2, plus 1I2, obviously. This is a KVL. And then it goes this way into the positive terminal, and if it enters the positive terminal, that is a positive voltage. And it goes into the negative 6 volts, so that is a negative 6. Because it goes into the negative terminal, equals 0. Now, our second equation for this, as I said in the steps, it's because I1 goes down here, and I2 goes up, according to the loop that we made, or we decided. We need to write the current source in terms of I1 and I2. So 4 milliamps, and since it's going in the same direction as I2, it's I2 minus I1. That's just the equation. And next, since we're gonna focus on I3. So we start off here, I3, that becomes 2I3. This part's like really simple. Then it goes into the positive 6 terminal, that becomes plus 6 volts, plus goes into the 1 kiloohm while the I4 opposes it, so that becomes 1 I3 minus I4 equals 0. Now for the fourth equation, we can see it's going to go down here, so positive I4 plus it goes into the 1 kiloohm while the I3 on the opposite side opposes it, so that becomes 1 I4 minus I3, and it goes into the negative 12 terminal, so minus 12 volts equals 0. And remember, since we have 4 unknowns, I1, I2, I3, and I4, we need to have 4 equations, which we do over here. If you don't have 4 equations and you have 4 unknowns, then you're doing something wrong. You always need to have the same amount of equations as unknowns. So according to this, I1 becomes negative 10 over 3 milliamps. I2 becomes 2 over 3 milliamps. I3 is equal to 0 milliamps. Now, that does not mean that the current, for example, over here is 0. That just means that the current of the loop is 0. And I4 equals 6 milliamps.